Hello, listeners. Today we are releasing the final episode in our series entitled The Gene Simmons of Data Protection, the KISS Method, brought to you by none other than Protegrity. Protegrity is AI-powered data security for data consumption, offering fine-grained data protection solutions so you can enable your data security, compliance, sharing, and analytics. In our final episode, we are speaking with Michael Howard, CEO of Protegrity. We talk about how traditional type systems often fail short in modern data management, as well as potential threats posed by quantum computing to current encryption methods. In addition to this, we talk about how Protegrity's product embeds context and security into the data itself in order to repel any threat. Well, Michael, thank you for being on the show today. Thanks for being on Code Story.
Hey, Noah, it's good to meet you, and thank you very much for having me.
Absolutely. Before we jump into our topic today, which is around, type systems, quantum computing, Protegrity's innovations, and how to navigate the future of data management, tell me and my audience a little bit about you outside of Protegrity, outside of maybe technology.
I've been in the data or information business for so many years, I don't even want to say anymore. Perhaps I could be the father of many of your listeners. I consider myself an expert in the database and AI ML area. And then the third part of my expertise is security. So this conversation is very interesting because it coalesces basically my background together. Outside of doing these types of interviews, I do a very aggressive style yoga, which is called Ashtanga, and every other position is a free-floating handstand. So that's the way I invert my universe and disconnect from the trials and tribulations of dealing with this wacky world that we're living in. I'll name some yoga poses and we can talk about type systems and yoga poses. That might be a good one.
If you could connect those two, that would be pretty radical.
I'll try.
Okay, so title for today, Navigating the Future of Data Management. So, we'll talk about type systems, quantum computing, and Protegrity's innovations around those specific topics. So just to dive right in, I know that you've referred to type systems as quote unquote lame. Can you explain the concept of type systems in databases and why you consider them to be lame and why they pose challenges for modern data management?
Sometimes we hear about all these big things happening in AI or data centers and the billions of dollars that are being allocated to all sorts of Gen AI workflows and intelligence and all that. But the community, the people around this are not really knowledgeable about some small things that make a big difference in accuracy, reducing hallucinations, in making systems more reliable or have deeper integrity. And one of those things is what I'll call type systems. And type systems for database people like myself have been lame for a very long time. Because really, unfortunately, the database vendors really haven't evolved them. And what I mean by that is a type system, first of all, is something that types a particular type of value in a database. So if something is like your name, it's usually considered a character type. If something is a price of something, it's a decimal or integer. Those are two basic examples of types. But in today's world, it's not enough.
So in traditional engineering, I'm familiar with the types and how it can kind of categorize the data that is going to be stored in a certain field. But why is it not enough today?
Because when you're for example, when you're training a model, and the more data you give a LLM, for example, the better it is. But what if the information's not correct? We already have enough biased information coming from the internet, which is a huge source of fine-tuning models today. But when corporations start using LLMs to be able to go text the SQL or text the analytics, there's high expectations that the answers are correct. And if the database has incorrect information, then what happens is a very colossal and damaging domino effect takes place. And type systems, because they're so relegated and so, we'll go back to the word lame, in that they do nothing to determine the validity of the data. They do nothing to do the completeness of the data. There's no qualitative expectation or contextual building with type systems today. So one of the examples I gave, I was a CEO of a company many years ago, and its purpose was sales analytics, specifically pipeline analytics. And we were used for the biggest companies in the world. And one of these big companies called me up in the morning, Monday morning, I remember it vividly, and said, "Hey, Michael, your system sucks. It's not working because I can see that the numbers are not correct for our pipeline." And so I had my guys, everybody's up, trying to fix the problem. And what happened was one of their own DBAs literally deleted all revenue in Salesforce for the third quarter of their year. So the head of sales saw that there was a huge discrepancy between what he was seeing in my system and what he knew to be reality, but the system behind the systems didn't prohibit that from happening. So here you have this notion of a type that's supposed to protect the quality of data that is being put in a database, but yet a DBA could delete an entire quarter of revenue for that company, which was, by the way, not insignificant. So you ask yourself, what if the same situation, unknown by an AI Python guy, was training an LLM to do analytics for that company, text analytics, and whether it's ragging or fine-tuning or what have you, and a full quarter of information of revenue is missing? What happens?
The whole thing kind of goes off the rails a little bit as far as accuracy.
Yeah, it falls apart, right?
Yeah.
It's an empty suit of sorts, right? It's a system without the proper scaffolding or infrastructure that is just not being talked about today, because AI guys are not database guys. They're diffusion model guys.
For sure. I appreciate you walking through that. And that's not something I had really thought about. When you think about LLMs, obviously you think about they learn from data, but there's nothing sort of safeguarding missing data or incorrect data. And I think that's really interesting.
At least databases, forget about the non-structured database like Mongo or Dynamo, or think about a PDF, right? How do you know whether what is written down or the tables or the annotations on tables is correct?
I guess you don't.
You don't. So at least databases have type systems. But what I think is going to have to happen here is that there's going to have to be an evolution of metadata such that there is a index of truth and validity in the sources of data that are used, especially when LLMs take over the world. Now, why is this more important today than yesterday? You know why? Because I was trying to come up with a metaphor. There's a company called Hermes, the fashion company, and they make a purse called the Birkin. Jeff Bezos' wife was trying to get the first Birkin ever made. I don't know, it's like $50 million or something like that. And these Birkin bags are worth a lot of money. And the reason why they're worth a lot of money is because there's no way you can automate them. You hand build them. The craftsmanship is just really great. So when something is hard, when something you have to have a huge amount of expertise to do something, there's attention to detail. And if we go back before Gen AI, when the only way you could ask a question of a database is through some convoluted SQL and have experts surround that SQL, it's like building that Hermes bag. There's no simple way to really build exact secret. You have to be an expert in SQL. Well, now in this world, abstraction, automation, intelligent workflows are supplanting expertise. We see that in vibe coding, right? So the expertise is going to go away, and our reliance on this abstraction layer, LLMs, that are based on data that we don't know to be true. It's funny when you look at politics today, for example, they're reflections of one another. What is fake news? What is real? All these kinds of things, right? And they go hand in hand.
Okay, so then let's table that for a minute and let's go into a new topic here, and this is quantum computing, right? How is quantum computing poised to impact the current landscape of data security and encryption? And I assume it probably has a little bit to do with what we just talked about in certain capacities. Maybe not the types themselves, but the LLMs and AI and all those sorts of things. So tell me about quantum computing. How is it poised to impact our landscape?
Just LLMs, there's wonderful parts of it where you can have this intelligence help you get information, but at the same time, that intelligence might be faulty. It's like a Dr. Jekyll and Mr. Hyde situation, and the same is true for quantum computing. The difference between quantum computing and classical computing will be dramatically effective for a certain set of use cases, whether it be drug discovery, material science, financial modeling. And the fact is that all the big hyperscalers are building quantum services. There's one thing that stuck in my mind. There's a particular type of algorithm, a Broussard-Hire tap, or they call it BHT. For every 1,000 of quantum computing attempts is equivalent to 1 trillion classical computing attempts. The impressive performance of a quantum computer when working, you'll have a quadratic speed up of searching of unsorted databases, or making when you're using an LLM today, sometimes the inference latency is just very frustrating. All that could be gone. So really amazing there. But let's go back to the Mr. Jekyll thing. The thing that came into mind, I've been rereading Lord of the Rings, and I'm going like, wow, these quantum algorithms are no different than the Wrath Riders that are described in Lord of the Rings. They're going to blow out the current order of things. They're going to blow out RSA encryption. Digital wallets are going to be vulnerable. What's even worse is the fact that for the first time in our generation, the bad guys and good guys are going to be on the same system in the cloud because the hyperscalers are offering quantum services.
It's a little bit wild to think about. It can be a little scary when we think about that. It's kind of evening the playing field there.
Yeah, again, we're doing like before and after analysis here, whether it be on LLMs or quantum. At least when people had their own on-prem data centers and bubble-wrapped mainframes, today most of the world is migrating to the cloud into Snowflake, Databricks, Redshift, what have you. Even Oracle has their Exadata machines available on the hyperscalers. So all, payroll information is up there. And yet that bubble wrap has been snapped, ripped apart, and now the bad guys are juxtaposed next to all those systems. And then when you think of what Shor's algorithm can do to RSA encryption, so you have, again, this perfect storm that is happening between AI and quantum. It's a very dramatic period in our industry.
That's no doubt. Okay, I want to flip back to type systems and traditional type systems. What are some of those limitations? Like we talked about some of those limitations, the scenarios there, but how can they be improved? How can they be improved to handle, modern data challenges? And maybe this has to do with quantum computing, or eventually it will, but I'm curious there.
My original investigation into quantum, was there any improvement in the quantum world on data types? Because if you think of quantum, it's not black and white. You can have gray areas, and that's why quantum computers can be so much more powerful than classical computers, which is based on 1 and 0. In my research in quantum, there has been no improvement. So that's where Protegrity came into play. When I started investigating what Protegrity, and remember, as we're here because they're coming from a security perspective, but they're really more than just security. They're trying to ascribe behavior and policies to data. They're taking the notion of a type system, blowing it apart, and evolving it to a dynamic policy that's specifically ascribed to a data item, whether it be in a database or something else. And I just thought that was a very profound evolution that should be highlighted in today's discussion.
Let's move forward then, I think, into what you just talked about. Can you share insights into how Protegrity's approach to data classification and protection differs from traditional methods, right? Obviously, Protegrity is innovating and doing something different around data security. How is this different? And tell me about that.
When someone asks me about what does Protegrity do, the first phrase that I use is say, we're specialists in data-centric security. And that's distinguished versus when you go to RSA show, right? And you look around at the exhibition floor, what you mostly see are security vendors that existed 20 years ago, and it's mostly about DDoS or network security, the perimeter. Very few companies on earth today deal with data specifically. And so they have built up mechanisms, instrumentations, technology that's able to, for either a security organization or, in fact, a functional department in an organization, to think what are the right policies, whether they're about laws like compliance, HIPAA, Law 25, PCI, or whether it's sovereign issues like what can be shown in the United States versus what cannot be shown in Britain or India. And they have a mechanism whereby these policies can be specifically, again, ascribed to a data element. And I think that's really powerful.
So looking ahead, how do you envision the role of type systems evolving with the advent of quantum computing, right? And that aligns all with the things that we're talking about, the innovative approach for Protegrity and type systems and quantum computing. How do you envision this role evolving and aligning with, the advent of quantum computing and other emerging technologies?
One thing that Protegrity is working on in research is actually to create a new type, and that type would be able to have these types of policies ascribed to it that would be independent of anything above it. In other words, I'll give you one quick notion. There's new themes of democratizing data, and one of those, the manifestation of that is a new format called Iceberg. I don't know if you've had other people in your show talk about Iceberg, but for the first time, the big companies of the world are saying, why I'm generating my own special data, but yet I'm paying Databricks and Snowflake, Redshift or whatever, all this money just to house data that I created. And so now you have this new democratized format called Iceberg, and we're taking a first mover status on that, whereby we're going to put this type of new type system into Iceberg directly, such that everyone above it, like Databricks, Snowflake, Redshift, S3, and so on, even I think transactional databases like Postgres, will then be able to have the power of this policy mechanism and be able to change the world for the better.
That's really interesting and super innovative in bringing in a new type that's going to attach to these policies. I've got one more question here. One of Protegrity's talking points has been how far behind legislation for data privacy and security is, right? The data landscape is rapidly accelerating due to all the points that we've talked about: quantum computing, LLMs, AI, all the sorts of things. What do you think needs to happen in legislation for quantum, for AI, and for the conversations to turn into action?
I'm of two minds on that one. I remember being interviewed about when COVID ended and how different companies were trying to lure back people back into their offices, right? And we see challenges of having that today. So there was a notion of, do you pay more money? Do you threaten them? Do you have some new rule? What do you do to entice people to do things? And I never felt that legislation or external inducements would change that. You have to make it so it's valuable to be in the office, and in an analogous sense, you have to make it, how should I say, attractive to use these new type systems. I don't think the legislative body will ever catch up to how fast computing is. But here's where it's going to happen on its own without legislation. When the biggest, most important companies of the world find out that they can't close their books because they're using LLMs because of the lack of accuracy, they're going to come to people like Protegrity, and they're going to use this kind of system to be able to bring in a new level of integrity to their systems.
Yeah, that's going to cause a lot of action to happen.
Exactly. The need for integrity will not be a result of legislation. It will be the need of the business to survive.
Oh, that makes total sense. Well, Michael, I really appreciate you being on the show today. I feel like I've learned a lot about, how type systems aren't enough anymore. The old way of doing things and type systems just aren't enough. And with the advent of quantum computing, there needs to be a new wave of type systems. There needs to be a new way of types that keeps data secure and allows for the fast, correct, and secure learning of these types of systems. It's clear that Protegrity is advancing this agenda and in this area. And it's exciting to hear about these new types. It's exciting to hear about what you see in the industry will be the push for integrity. And that will push the conversation around, legislation. But even before that, it'll push the conversation around the need. So I really appreciate you being on the show today.
Thank you very much for having me. Appreciate the platform.
What a way to end this series with Protegrity by talking to Michael, the CEO of the company. It's interesting to think about how quantum computing is changing the game, and traditional type systems just can't hack it anymore. With the advent of AI and LLMs and learning from data, we need something new. And Michael illustrates how Protegrity is advancing that agenda with its innovation. Thank you for listening to today's episode. If you'd like to learn more about Protegrity, go to protegrity.com. That's PROTEGRITY.com. And thanks again for listening.